Seems we can get started. Hello, everybody. My name is Maarten de Kroos, and welcome to this webinar on getting started with product carbon footprint. We have quite some content to get through today, so I'll get right into it. Who am I today? I am Maarten de Kroos. I am the marketing lead for Climate Camp, and today I'm going to walk you through the different aspects of product carbon footprint calculations. Now, what are we going to talk about? First, I'm going to set the scene with some general information on product carbon footprints, some definitions, the relationship between corporate and product carbon footprint, calculation standards, and more. Then we'll talk about why should you calculate PCF, why should you bother with this type of calculation, and then dive into the theory of how to do it. Then the different steps which are outlined in the theory, I will also show in Climate Camp how we handle this for our customers. Then at the end, we will also do a short Q&A section. So if you have questions regarding PCF calculations, please do ask them. You can ask them in the chat. You can ask them in the Q&A section. There are also colleagues of mine in the chat, so don't hesitate to already ask them. Then they can maybe already answer them during the meeting, whereas I will only be able to answer them at the end of the presentation. So let's get started. Now, what is a product carbon footprint? Well, a product carbon footprint, when we talk about it, we always have to look at corporate carbon footprints. Now, I've taken a look at the people who are present in the webinar today. I think most of you are familiar with the corporate carbon footprint. It is the total amount of greenhouse gas emissions produced by a company's operations, supply chain, products, and services. This includes all the direct and indirect emissions across the three scopes as outlined in the GHG protocol. Now, a product carbon footprint is the total amount of greenhouse gases from a specific product, but throughout the product life cycle, from raw material extraction through manufacturing, processing, transportation, usage, and end of life. The best way to visualize this is with this graph from the GHG protocol, where the blue represents your corporate carbon footprint and the green represents a product carbon footprint. A corporate carbon footprint is comprised of many different PCFs and then some categories added on top, like business travel, employee commute, and other general categories. But a product carbon footprint is a slice of a specific profile, corporate carbon profile for a company. Now, this is the relationship between corporate carbon footprint and product carbon footprint from a calculation principle. But why does it matter from a principle of investments and optimization of your emissions within the organization or outside of the organization? Well, it's because they relate to different priorities, different insights. I've drafted a quick example from a packaging company, packaging manufacturer, and I've simplified the numbers just to make it easier for this webinar. So if we look at their corporate carbon footprint, we see a large part is purchased goods and services. Some percentage comes from electricity use. Some percentage comes from transportation, employee commute, and business travel. Sustainability manager, sustainability director, or somebody else within a management team could look at these numbers and go, okay, we need to engage suppliers. We need to get more specific information. We need to improve the energy mix of our factories or optimize energy use for factories, and then optimize the transportation we perform. Whereas if we do product carbon footprint calculations, we see this company produces two types of products. It has a plastic tray and it has a paper-based cup with bioplastic lining. We see the plastic tray has a higher PCF because it uses fossil-based plastic and energy-intensive molding. And product B has a lower PCF, but we need to source the bioplastic from China or somewhere far away. So here, the decisions for optimization or the investment decisions are much more specific. For example, for product A, it might be switching materials or investing in the energy usage of your supplier. Whereas for product B, it could be more about sourcing bioplastic locally. So the granularity of the decisions that can be made are different between CCF and PCF. Now, calculation standards, I think most of you know this as well. Greenhouse Gas Protocol and ISO 14067 are the standards that are most commonly used for PCF calculation and guidance. Now, why should you calculate PCFs? I've done this webinar or the content of this webinar 5 months ago, and I've quickly went over this topic and dived right into how to calculate PCF. But I think it's an important question to ask nowadays, why you should become or why you should calculate PCFs and become a preferred supplier. For example, CSRD might be postponed, but actual reduction and target setting is actually still as relevant as ever. I checked yesterday on SBTI, and there are 156 retailers in Europe, corporate retailers, who have targets set, not committed, targets set. And there are more than 2,000 companies in total that have targets set. That means these companies will start looking at their value chain, because they are corporate companies, as to how they can reduce their Scope 3 emissions. If we look at the number of companies that has set near-term targets, it has nearly doubled in the last 18 months. So it's not like people are slowing down or quitting with reduction targets setting. But what does that mean for you? Well, the likelihood of you having to set reduction targets will increase, or the relevance of delivering PCF data for your customer so they can reduce or calculate their reduction will also only go up. The second, and this is a discussion I had with a retailer a couple of weeks ago, there is an important nuance between emission hotspots and reduction potential. What do I mean with that? I've visualized an emission hotspot like we have in Climate Camp here. It could be that for retailers, certain product categories are the largest emitters. For food, for example, this is classical meat and dairy that are the highest emitters, and produce is a strong third. But generally speaking, there's more reduction potential in crop farming than in livestock. Not for every produce and not in every case, but generally speaking, there might be more reduction potential in certain categories than in others. So retailers know their emission hotspots, but they are looking towards what is the potential for reduction in the different categories we have. PCFs play a really important role here. For non-food, the same thing applies. Apparel and footwear, electronics, furniture are major emitters, major emitting product categories, but there are large differences between the different products depending on where the raw materials are sourced, how goods are transported. So the reduction potential is something retailers are now trying to get more and more insight into. So if you can showcase the reduction potential your products have, it will become a strong negotiation variable in the future. The third aspect is you can't compare intensity-based corporate carbon footprints with product carbon footprints. We know companies who do this. It's not, people are still finding their way as to what the best practice is. But the fact of the matter is you can't compare intensity-based CCF with PCF. For one, elements such as business travel, employee commutes, etc., are calculated in CCF and not in PCF. And PCF creates a more comparable metric based on processes and materials, allowing you and your customers to compare evolution of PCFs over the years or between suppliers, given, and this is important, there is still a nuance, the documentation has to indicate that it is the same system boundary, the same production steps to make sure that it is comparable to compare PCFs. Third-party verification here is your best friend. Now, CCF and CCF intensity shows organizational investments, whereas PCF shows value chain investments. As I've mentioned before, suppose you purchase a certain raw material and it's more sustainable than what you purchased before, or you purchase a certain amount of it. In the grand scheme of your corporation, it might only mean a slight reduction of your CCF. You buy a certain batch, but you have many different products, you have many different sites. So in the grand scheme of things, it has a minor CCF reduction. Whereas if you use the sustainable sourced goods for a specific product, it might have a major impact on its PCF value. And then you can use it. I always say PCF is a commercial driver, not a compliance one. Then you can use this PCF value. Then you can use this story of using these sustainably sourced goods to showcase, we sell primarily to this retailer. This is the amount of reduction we are able to achieve for this specific product. So it showcases much more the investments you have done in the value chain, whereas CCF is more on an organizational level. And I always say companies buy products, they don't buy chunks of your company. So they try to use intensity-based CCF to get a view of your maturity and your improvement, but PCF is how they can actually simulate reduction potential. Now, why should I calculate PCFs? It is an important step in developing Scope 3 maturity. Now, this is a graph. You will have seen similar graphs if you have spoken to consultants related to target setting, related to improving your carbon maturity or other tools, for example. And this is something we see for many different companies. Obviously, most companies started with Scope 1 and 2, but we're going to skip over this. But the first step being, we do full corporate carbon footprint calculations, and companies do priority PCF calculations. Priority PCF for the goods that comprises most of their revenue or are for their most important customers. They don't do calculations for all PCF for all their products, but they do for certain products for product segments. Or, and this is something we see more often as well, when they create a new, more sustainable product and they want to leverage that towards the markets. In this calculation step, they will often use industry average emission factors before moving on to the next stage. Now, I have engage and target here as a sequential steps. What we often see is that target is placed first and then engage as well. Whereas this is possible, but we have also seen the effects of doing it in a reverse order. What often happens, or what sometimes happens, is targets are being set, primary data is collected, being for CCF or for PCF, and then you come to the realization that you have to re-baseline or that your reduction targets are very unrealistic, which creates a lot more work and a new action plan to reach your goals. So we always emphasize doing supplier engagement to collect primary data from the most important suppliers or the most important raw materials. The last element for why you should calculate PCF is to form a reduction action plan. Now, I've spoken to many sustainability managers, and obviously the topic of reduction often comes up, not just carbon accounting, not just calculation. And a lot of companies are already on track with everything within operational control, making investments to install solar panels for scope 1, change to electric cars, make stricter business travel rules, etc., because it is within their operational control. However, when you look outside of operational control, scope 3, especially purchased goods and services, especially transportation and packaging, it's hard to see what are the best actions that can be taken to improve or to reduce your carbon footprint. Now, what we generally see and what we see a couple of our customers are already moving towards is identifying what parts of the supply chain to invest in. And PCFs help achieve that goal. For example, we can simulate investing in electric trucks for shipping product A, for example, can yield an X% reduction. Increasing a percentage of regenerative crops for product B can yield a Y% reduction. Co-financing installing of solar panels for your supplier can yield Z% reduction. The first two examples are actual examples that Climate Camp customers are already trying to implement. The third one is an IKEA example, who is heavily investing in, for example, the processing of woods in Southeast Asia and helping their suppliers switch to more renewable energy. What you need to keep in mind here is that confidentiality is important. You keep detailed info of your PCF calculations because you don't want to give the secret sauce of how you make your products or where you get your goods from, but it helps you to propose reduction simulations towards your customer. So these are the primary reasons why you should calculate product carbon footprint. So let's dive into how should I calculate it. You first start with defining system boundaries. When you calculate product carbon footprint, we're talking about the entire product lifecycle from cradle to gate to grave. So from raw material extraction, processing, manufacturing, distribution, up until usage by the customer and end of life. Now, the two main system boundaries we come across are cradle to gate and cradle to grave. Why these two? Cradle to gate is often used to share PCF data with your customers. Why? Because you avoid double counting. If I calculate a PCF and my customer calculates a PCF and we do cradle to grave, we will start double counting for steps of the production process. Whereas cradle to gate will ensure that only all the emissions are calculated up until your manufacturing, when the goods leave your manufacturing units. Cradle to grave then obviously is full life cycle analysis. This has much more relevance for LCAs and improving product design, for example, when we're talking about how can we improve reuse, recycling of our product, how can we extend lifetime, for example. So cradle to grave is much more used in LCA analysis. And when we look at gate to gate, so what happens between your products when raw materials enter and your products leave, it's more about in-house optimization. So generally for PCFs, we will use cradle to gates. Once you've defined cradle to gate or chosen cradle to gate as a system boundary, you will move towards defining your production steps. So what are the different steps your raw materials go through, processing, etc., up until they reach your factory, until they are manufactured into a final product? The most common ones obviously are raw material extraction, material processing, distribution, or the delivery of transport between the raw materials and your organization. Use phase and end of life is more relevant for cradle to grave. Now, after we defined the production steps, we need to make a production process map. What does this mean, a production process map? I have here for the next coming slides, I'll use the examples of making beer, for example. So here, a production process map is we list all the different stages, raw materials, transport, the processing step of malting, brewing, and packaging, for example. And then for each of these steps, we'll define what goes in, what goes out, what is the specific process that happens, and then trying to find an emission source which is relevant or relative to this stage and these different elements. So for example, in transport, the input is fuel and shipping materials, the process is we use a ship, and then the output says the malt is delivered to our organization. So the main emission source will be diesel combustion in the ship. Mapping this out will make sure you don't miss any gaps in the value chain or the supply chain of your products, as well as not missing any emission sources. For example, fertilizer use will have a different emission than CO2 equivalent, which can also be very relevant, or land use, which is also a very impactful category. After you have defined all these stages, inputs, processes, outputs, and emission sources, you go towards calculating the emissions for each one of these stages. Now, before I give the example of the calculation, I'm going to give two specific nuances that might be relevant to your organization. The first one being account for internal transport. What we often see with customers is that, for example, certain raw materials arrive on sites, but they are then shipped to another production company or a processing company before they are shipped back again to be entered into the product or for distribution. All these different steps should be accounted for as upstream transportation. Another example is cradle to customer. Maybe you have certain products which go straight from your supplier to your end customer. Well, in that case, seeing as you have no insight into the production, you can only use emission factors from materials and rough transportation legs. So cradle to customer is when you don't actually do manufacturing or processing yourself, but drop shipping is a good example of this, where you calculate based on cradle to customer. Now, how do you calculate product carbon footprint? I've mentioned it before, you have this production process map. So for each one of these processes, we now have to calculate how much emissions are generated. Now, you need to choose an allocation methods, and allocation methods will define how granular you can assign certain activities or emissions to certain processes. What does it mean? For example, we always will try to allocate by process. Suppose you have a machine in your organization, in your factory, and that machine is dedicated solely to the creation of one product. Well, then 100% of the energy use of that machine will be allocated to that process. It cannot be simpler, but the reality is that often machines are used for multiple products, to create multiple products, to process multiple products, to package multiple products. So if you cannot allocate by process, it's important to have a fallback. The first fallback being mass. So if you can divide, I have a machine, and for this product, this many kilograms goes in, and for that product, that many kilograms go in. That is a very good allocation method you can use if you have insights into the inputs and outputs, which I mentioned before. Other fallbacks are economic, so the amount spent on a certain activity, or other physical variables such as energy or volume content. Now, this might all sound very theoretical, so I'll simplify it with an example. As I said before, I've used a beer example to do product carbon footprint calculations. Here, we're talking about allocating the energy for processing the beer, so for brewing the beer. And here you can see we have a brewery, and its total energy use, electricity and gas, was 12,000 kilograms of CO2 equivalent. We found an emission factor for purchased electricity, the grid electricity, for example, and we've used natural gas. So we have estimated 12,000 kilograms was used or was emitted during production. But we brewed two types of beers. We brewed an IPA and we brewed a stout. The IPA uses a medium fermentation time, whereas the stout is much longer. So there is a difference in the total energy used. There is also a difference in output. There is much more IPA brewed for this amount of energy than there is stout brewed, because it has to ferment a lot longer. Here we can see the difference, 45% for IPA of the total energy, 20,000 liters brewed, 55% of total energy for the stouts, which means 10,000 liters brewed. Now we allocate the emissions. We divide this 12,000 kilograms according to 45% and 55%. So we can see how much emissions were generated for the IPA for this production batch and the stout for the other production batch. And then if we want, we can calculate PCF per liter for processing and electricity use. So here we can divide the 5,500 kilos for the IPA according to the 20,000 liters, which gets us 0.27 kilograms of CO2 equivalent per liter and 0.66 kilograms CO2 per liter for the stout. Now, this is just for the processing steps, just for the electricity used when brewing the beer. Now, we also purchase certain goods when we want to create beer. We need to purchase malted barley, hops, water, roasted barley. And here we again have the two examples, the IPA and the imperial stouts. As you can see here, the barley used per can differs. For the IPA, we only need the malted barley, which is 200 grams. Whereas for the imperial stout, we use more malted barley, 250 grams. But we also use roasted barley, which has 50 grams of content. Here we need to get the emission factors for both of these barleys and then calculate them into the result. So we need to calculate everything up, multiply the emission factor times the grammage or the kilograms that are used. And then we come up to a total raw material emissions per can. Here it's 0.11 kilograms of CO2 equivalent. And for imperial stout, it's 0.155. Now we have calculated it per can. What is really important is that, we see this with a lot of our customers, PCFs are generally calculated per production batch, not specifically per can. Also because it is then more easily to divide it back down to the can. What do I mean with that? For example, in my previous examples, I used PCF here, the kilograms of CO2 equivalent per liter, whereas here we calculated the raw material emissions per can. So when we ultimately want to calculate the PCF, we need to normalize it for the same production batch. So for example, if we have one production batch, which is 20,000 liters, well, how many cans is that? How many pallets is that for packaging? Because the transport might be per pallet, the packaging might be per can, and processing might be per liter. So it is really important that you normalize all the values you have for the production batch that is created. Because ultimately, when you then receive your PCF value, for example, in this example, it's 20,000 liters is 32.1 tons of CO2. It then becomes really easily to calculate it per liter or per can. So always normalize for the same production batch. I think this is really important. This is also something I will show in the demo later. Now, some best practices before I start showing it inside the platform. First one, overestimate, never underestimate. When improving data granularity, the hope is always that the amount of emissions you purchase or that you generate during processing will go down, but the reality is that this is not always the case. And we can assure you it's much easier having to reduce less than suddenly having to reduce more, and it also creates different problems. Understand the underlying studies. An emission factor is just as good as the relevance of its underlying study. You need to understand the different variables related to it when assigning them to avoid costly mistakes. I've pulled a slide from one of my previous presentations on corporate carbon footprint, where I pulled the emission factors for aluminium, which had more than 10 or 15 different emission factors, which has values between 0.3 and 16 kilograms of CO2 equivalent. All these variables had to do with where the study was done, the system boundaries, production routes, if it was recycled or not, what allocation methods were used. So it is really important that you understand the underlying studies, and if you don't, that you work with emission factor experts to validate your findings. You might be a sustainability manager, you might be a quality manager, you don't have the expertise of all the different emission factors and all these different studies. We always recommend, if you do it directly, if you do it via consultant, if you do it via a tool like ClimateScamp, to have emission factor experts validate your findings. It will be really important when you start making reduction plans and setting reduction targets that these findings are correct. Now, a last thing before we move on to the demo and showcasing how we do it in ClimateScamp is when you use PCFs from suppliers, I want to give some best practices going forward. One is, did they account for loss of material? So in transport or processing, there is often a certain amount of material that gets lost, but you have to ask yourself the question, did your supplier take this into account, or how did they communicate this value towards you? Did they ship a ton of wheat and lost that 100 kilograms, or did they account for it and sent more than 1,000 kilograms of wheat, but only report 1,000 kilograms? So this loss of material is something that is really important in PCF calculations to take into account. The second one is ask for documentation, but respect confidentiality. The things you can ask for are system boundaries, the PCF value, the level of detail, or the calculation methodology. Maybe you can ask production steps if it is a very well-known production or processing step, so it doesn't involve confidential information. But oftentimes the production steps will give information as to the secret sauce of the company or the supplier, how they will make up their products, how they will create certain raw materials. So oftentimes the production steps and specific calculations are not something you ask for. The way you solve this is to ask for verification. I've mentioned it in the beginning of the webinar. Either ask for verification from your PCFs, so from your suppliers, that's only PCFs that have been verified can be used in calculations for your PCFs, for example, or your corporate carbon footprint, or offer verification support yourself. We've seen some of our customers or other customers help their suppliers by linking them with a verification consultancy or agency that can do verification for them. Because being audited for a CCF is already difficult. It will raise a lot of difficult questions. If you use PCFs from suppliers, the amount of data related to your findings becomes even larger, and answering the questions for operations which are not within your control becomes even more difficult. So for PCF, this verification, third-party verification, becomes really important. Now, let's go to ClimateCamp and how we calculate product carbon footprints in our platform. Now, I first need to log in. Let me see if it's problem on my side. My apologies. I know what the problem is. Voila. Sometimes you start forgetting all the different passwords you have. Let's move on to how do we calculate it in ClimateCamp. So as we mentioned before, we define the different production steps. So let's assume cradle to gate because we want to calculate PCF towards our customer. So we define the different production steps as raw materials, processing, packaging, and transportation. You can, in ClimateCamp, set up this structure. You can even create substructures where you create, for example, the different raw material categories to make it more easy in your reporting to see the impact of different product categories on your PCF. After you have set up the emission groups, you go towards activity calculation. Now, I've already done the activity calculation. I'll group it by emission groups so you can see a bit more detail as to the calculation. And here you can easily implement for each of the emission groups mentioned before what activities have happened. Obviously, you can also do it via an import functionality, which showcases how you can import an Excel and then assign the information. But for now, I'll show two quick examples. For example, if I want to add raw materials, I want to add citric acid, for example. In this case, I am making a carbonated drink. Then we can easily say, okay, for the citric acid, for the production batch, because we are here talking about a production batch of 50,000 liters, I need 45 kilograms of CO2 of citric acid, and I need it in the periods of 2024, for example. Now, if I'm not sure how to allocate emission factors, we will do it for you. So if I save this, then we do a first automatic calculation within the day, and then our expert will validate it within the week. But if you are knowledgeable of emission factors, you can always supply an emission factor yourself. Then you can consult all the different databases, EcoInvent, DEFRA, GLEC, depending on what type of emission group we are talking about. So in this case, it's citric acid. You can see here we have the value from EcoInvent 3.11, and we also have a link to where the full documentation of this emission factor is, where we got it from. You can then select it, and then we will recalculate the specific emission factor with the value for 45 kilograms, which you have assigned. Suppose you have PCFs from your suppliers. I didn't add one, but let me just quickly add one, for example. I'll use one of our demo accounts. If he has PCFs published and they are shared with me, I can also, this is chocolate, it's not relevant for carbonated drinks, but you can see here that it will give a specific PCF value for the products that my supplier is sharing with me. So you can easily choose between either industry emission factors from EcoInvent, from the different databases, or you can send a request to your customer to share PCF values, after which you can implement it into your own calculations. I'll go out of it. Here you need to do some manual assignment of EFs if you know your emission factors, but we will help you with an automatic assignment in a day and in a week with all the expert validation. But for example, electricity and gas, we do it automatically directly. Just for example, let's say the electricity during processing that is used, I am using, for example, electricity for some part of the brewing process. I can then enter, okay, I have used 10,000 kilowatt hours of energy for the period of 2024. Then I can also add the energy mix, but let's not for purposes of this demo. Then if we do this, quickly refresh, it was set as a draft. So we have electricity brewing here, and now the value has already been implemented. Something that is important here as well, we will do, you can see if you edit this activity, you can see what emission factor was used. Obviously, we do this automatically, so we check with you if you really know what you're doing to be able to change this. But if you do, you can quickly click this, and then you can see where the emission factor was pulled from. So here it's electricity supplied from the grids, production mix from Belgium in 2021, for example. All right. The second part is Vera. So we calculate the emissions generated from the electricity you use at your factory for everything that happens from tank to wheel, sorry. But we also calculate Vera emissions, so everything that happens from well to tank for electricity, or specifically also for gas. So this is scope 3, category 3. We also automatically calculate this within your product carbon footprint. After you have calculated all these activities, you can get an emissions overview. Here you can see the emissions overview for this PCF, for example, and you can dial it down to what the specific emission groups account to. So let's say, for example, I want to know the impact of packaging. Is 15.36 tons of CO2 equivalent of the 25 tons, which was the total, the 24.73 tons in total. So this is how we calculate PCFs in ClimateCamp. We set up an environment that goes through the different production steps and then assign activities for each of the different steps. Afterwards, you can create an overview to see the different scopes. So scope 1, 2, and 3, what is the impact of this PCF? And then you can easily follow up from there. One more thing I wanted to show you is, I mentioned before the relevance of using PCFs from your customers. I already showed this from the Staines chocolate factory. I'll show it here as well. So if you list product carbon footprints, for example, and you want to share this with your customer, we make sure that the documentation is extensive. So not only what is the value, what is the reporting periods, but also are there emission details you need to share? Does it include packaging or not? Are there biogenic emissions, fossil carbon content, land management, and other land use or flag categories which are relevant? And especially, as I mentioned before as well, is there assurance available? Has their third-party assurance been done? And if so, can you upload the PCF report or the assurance report, which is linked to your PCF calculation? This way, you can ensure that you only use verified PCFs in your calculations, be it CCF or PCF calculations, and not just any value. So that is something important to keep in mind, that you get high-quality PCF data when you are calculating it yourself. I think, okay. I will now go back to the presentation. Voila. So that was a short demo of how you can calculate product carbon footprints in ClimateCamp yourself. Now, I didn't see any questions pop up during the meeting so far, but let me just quickly check the Q&A section. What is the most significant gap in calculation methodology when comparing companies' current corporate carbon footprint to the requirements for calculating a robust product carbon footprint? I see that Ruben has joined me. I assume that he has seen this question.
Yes, I have. So maybe on the first question, and I think, Maarten, you addressed it quickly as well. If you look at the requirements for corporate carbon footprint, we often look at the 21 categories from the greenhouse gas protocol, where on the product carbon footprint we look into a very specific scope of the process. So you'll see that, and I think, Maarten, you brought an example of the employee commute being included or the business travel being included on a corporate carbon footprint, where typically those are seen as non-significant in a PCF calculation. They will not be included that often. But I think the biggest thing to look at before using, and because what we sometimes see that some customers use intensity-based corporate carbon footprints as product carbon footprints. Although in some industries it can be looked at, but there it's very important to look at how streamlined the products are that are being created by that supplier. So let's, for example, if we take the brewery example, if you get primary data from a maltery which produces a specific type of malt, they're using the intensity-based emission factor will be less impactful than if you would, for example, work with an intensity-based emission factor for a packaging company which produces different packaging and has a big variety of types of packaging to use, so that the intensity-based will be even further away from the PCF than expected.
All right. Thank you, Ruben, for your explanation. Yes, as I mentioned before, it is really important to to compare apples with apples and oranges with oranges. Intensity-based CCF versus PCF has a different value when using it. The second question is, given the variety of supplier-specific calculation methods already in use for existing CCF reporting, what are the primary challenges and recommended strategies for standardizing this data to align with a consistent product carbon footprint reporting framework? The question, it's a rather broad question. My question then becomes, do you mean how you can share PCF data between different companies, or like between your customers or your suppliers towards you? Or how do you mean with standardizing this data, Hugh? Maybe you can answer in chats if you're still here.
Maybe I'll already answer then on the some, because I also didn't fully get it, but on the question like how to exchange product carbon footprint data with ClimateCamp, we have chosen to follow the PACT framework, PACT. It's definitely interesting to look into when it comes to gathering primary data from suppliers and exchanging PCF data. What we do see that is very, very, very important to really look into the data that you receive. Suppliers provide different or sometimes a bit, how should I say that? So sometimes suppliers are a bit inventive in the data that is being provided. So it's very important to do quality checks on that. Of course, the best quality check is to look if there is any assurance being provided on the calculations. Unfortunately, these assurances are quite costly and sometimes or often absent. Next to that, what we always advise is to really look into the specifics of the PCF. So to not ask for just a simple number of like, okay, what's the carbon emissions of that product, but really ask insights on the boundaries and the scoping of the calculations. If possible, a distribution between processing, packaging, and transportation emissions, and also comparing the PCFs with the industry averages being used today. And if there is a significant difference, to still reach out to the supplier to try to understand where this difference is coming from. So I hope that answers a bit the question being asked, but don't hesitate to follow up if it doesn't.
Yeah, you just clarified a little bit more. If he has different suppliers for one product, how can we standardize the data? It's used with different methods, so we cannot really compare. I think this is what happens really often, and that's why we also mention use verification and set clear guidelines for the same calculation methods and communicate this towards your suppliers, because you cannot compare it otherwise. This is one of the difficulties with PCFs, that you need to make goods agreements with your suppliers that PCFs become comparable. And the way to do that is verification through third parties, as well as outlining what are the boundaries you are looking for and what steps are included within the calculation.
And maybe to add a last part to that as well, Maarten, as it's quite an interesting topic. What we see sometimes is that it's very interesting to see the proportionate impact within a PCF, to see, okay, how much is related to electricity, how much is related to gas, how much is related to packaging, how many emissions are related to transport, because that's when it comes to actions, allows to gather insights on like, okay, how big are my levers or my suppliers? If a specific supplier is delivering quite some products to me, what we do now for some customers is to try to estimate the impact of being able to switch that supplier towards, for example, fully renewable energy. So that's less on the comparing aspect between suppliers, but rather we're getting insights on like, okay, which proportion of the total emissions is related to which kind of activities, and if you would be able to change something on the activities of the supplier, what would be impact on corporate carbon footprint, where it matters a bit less on what the exact emissions are, but rather the proportions.
Yeah, I think this is something relevant that Ruben also mentioned. How we experience it with a lot of our customers, PCFs right now are not really used that much to compare A versus B, but more to compare or to evaluate what the reduction potential is, to see how can we improve for the existing suppliers we have, how can we collaborate, how can we work together to improve transportation or to improve energy use. So PCFs are more used in that regard today than they are to compare suppliers directly. I'll go on to the next couple of questions. We have a question from Tarpan Yazim. What's the most efficient way, in your opinion, to integrate data from supplier PCF declarations? Should we always verify them internally? And if we cannot engage our suppliers, what is the best way to assume a PCF calculation?
Maybe I'll take this one. So the best way to assume a PCF calculation, you'll notice that a lot of suppliers are not able to provide PCFs yet. We, however, see a big catching up in the market the recent years in being able to provide these PCFs. But it can be that your suppliers don't have a PCF, or that the organization does not have the resources to engage suppliers. Of course, that's something that ClimateCamp does for our customer base. In case of not using ClimateCamp, what we see is still the fallback on industry emission factors. So using the average emission factors in different databases, like an EcoInvent, a Blanc, an Agribalise, and so on, to be able to use that instead of the prime data from the suppliers. The challenge there is, of course, that over the years, the efforts that your suppliers are taking are not reflected within these emission factors being used, where while using primary data from a supplier, you would be able to see the impact of actions of your suppliers. And then
I'll also maybe answer the previous questions, and it relates to something I said before. What we see, for example, I talk to a lot of corporates surrounding this topic. They only integrate verified PCFs, generally speaking. If they actually use them in their own calculations, they need to be verified. They need to be a certain level of assurance given with the PCFs before they can be integrated into their own calculations. Otherwise, it's a good metric to see what is the general value or how can optimizations be done with regards to these products. But to actually integrate them, you should first verify them internally if you have the capacity, but also have third-party verification or assurance before you integrate these numbers.
It's maybe attached there because, as indicated before, verified data will not always be available. It's like we indicated before, is the verification is very important of the data. Please don't use PCFs as is and receives, but really check, okay, how do they compare with industry averages? What are the boundaries? What's the underlying data points being used in it? So this verification is really key.
Yes. And then I'll answer the last question of Liesel Boutsen. So if I understand correctly, in Climate Camp, you use the top-down approach using allocation keys. Is the bottom-up approach also provided in the software? Well, we have I think we have different views on what bottom-up and top-down is. What we do is we can choose which type of allocation we apply for what part of the production process for what production step. So for example, for energy use, it could be a top-down approach where we allocate according to the energy used during a certain process. But for raw materials, it's bottom-up, for example, where we take the different components that comprise your raw materials, for example, and then calculate emissions for PCF that way. So we look at it more as choosing a type of allocation method, which I mentioned before, using it by process, using it by mass, using it by economic factors or by energy or volume content, rather than just seeing it as top-down or bottom-up.
Usually what we'll do is we'll go top-down if the data is not available. We see it very often for processing emissions, let's say, for example, electricity allocation, which cannot be done for a specific production line. In those cases, we'll go for top-down. But then definitely, as Maarten indicated, for when it comes to the bill of material, the raw materials, the packaging, transport, they really work bottom-up. Depends on the data that is available. So the answer is yes, both are possible, Liesel.
Okay, but if this was not really clear, I'll take this feedback towards the next demo, or I can always show you directly later. I think these are the last of all the questions we had. They were really interesting questions. We will take these with us for coming webinars. So I want to thank you for sharing it with us and asking them of us. And then I want to do a quick shout out before we end the webinar. We have an upcoming webinar in 3 weeks. So I talked a little bit about reduction targets. I talked about that there are more companies setting SBTi targets, as well as a lot of companies already working on reduction in Scope 3 and also Scope 1 and 2. So in a couple of weeks, we'll talk about how to set and achieve Scope 3 reduction targets. So before you want to set reduction targets, how to estimate how much reduction potential does my value chain have? Where can I reduce if I can reduce? And then what is the nuance of setting reduction targets? And then not only setting the targets, but actually crafting action plans to achieve them. So sourcing lower carbon products, making investments, collaborating with suppliers, for example, to reduce your footprint. This will be in 3 weeks. I will send a mail with the recording and the slides of this webinar and also a link to register for this upcoming webinar. So we would love to see you there. I want to thank everybody for joining us today, and hopefully we will see you in a couple of weeks. Thank you very much.